So we're in section 3.12, solving systems of linear equations. So when we model any given system, we could have two equations. So for example, as mechanical engineers, you're going to model for a spring mass system. Then we have two different equations. So at this time, we have x1 and x2 respect to t domain. If that is the case, we need to solve for x1 and x2. So we have two differential equations and they have x, y respect to t. It's gonna hard to keep writing dx over dt, dy over dt. So what we're gonna do, we're gonna say d over dt equals to d. Anywhere you see d over dt, we're gonna put it in d. Then the first equation is gonna be dx plus dy plus 2y equals to 0. And the second equation, we have dx minus 3x minus 3y equals 0. Once you have changed d over dt as a d and write this equation, now using one equation or both equations substituting method, we need to have only one variable. Somehow we need to substitute x to y so that we have only y, or y to x and all the x's. This so that dx equals to 3x plus 2y, and then you plug it in here. Then we have 3x plus 2y plus dy plus 2y. Well, I still have 3x, so if I let 3x equals, so let 3x one side and the other one move the other side, dx minus 2y, you plug it in back, we still have a dx. So this is the example of using wrong equation to wrong substitution. You are not going to get only one x when all the x is one side or all the y is one side. You are not going to get that. So this is not good. The reason that this is not good because I'm using the x equals to x terms plus y terms, right? In this line. However, if I do move 2y to the other side, now we have 2y equals to dx minus 3x. Now y equals to only x term. So this is the good example. You should let y equals to all the x terms. Y equals 1 over 2 dx minus 3 over 2 x. So we're going to use this. If you're looking at the first equation, we have dy and y. So I'm going to find out what's dy from here. Then 1 over 2 d square x minus 3 over 2 dx. Now let's plug it in. dx plus dy plus 2y and 1 over 2 d square x plus 1 minus 3 over 2 plus 1 dx minus 3x equals to 0. And 1 over 2 d square x plus 2. 4 over 2 minus 3 over 2, that is 1 over 2 dx minus 3x equals to 0. I'm going to multiply everywhere by 2, then factor out x. This is a homogeneous differential equation, and the Ox equation is going to be m squared plus m minus 6 equals to 0. And from here, you can factor out m plus 3, m minus 2 equals to 0, and m equals to negative 3, m equals to 2. So the solution x equals C1 e to the negative 3 t plus C2 e to the positive 2t. Once you have x in terms of t, now we need to find the y. Up here we said y equals 1 over 2 dx minus 3 over 2x, right? So I'm going to copy that down. Y equals, take the derivative, dx equals negative 3c1 e to the negative 3t plus 2c2 e to the 2t. We'll use those. 1 over 2 dx negative 3c1 e to the negative 3t plus 2c2e to the 2t minus 3 over 2x c1 e to the negative 3t plus c2e to the 2t. Y equals negative 3 over 2 c1 e to the negative 3t plus c2 e to the 2t negative 3 over 2 c1 e to the negative 3t minus 3 over 2 c2 e to the 2t. So negative 3 over 2 c1 minus 3 over 2 c1. We have a negative 3 c1 e to the negative 3t and 2 over 2, so minus 1 over 2 c2 e to the 2t. These are the two. So first equation is going to be dx equals 4x plus 7y. Second equation, dy equals x minus 2y. From second equation, you let 2y equals x minus dy. That's not good because y equals x and y. But if you let x equals dy plus 2y, that's good because x equals to all y. From the left side, dx, so you let 7y equals dx minus 4x. This is also good. Then y equals 1 over 7 dx minus 4 over 7x. Then you can do dy 1 over 7 d square x minus 4 over 7 dx. Use these two to substitute here. Then x equals dy 1 over 7 d square x minus 4 over 7 dx plus 2y plus 2 over 7 dx minus 8 over 7x, 1 over 7 d squared minus 2 over 7 d, and we have 8 over 7 and 1, negative 1, negative 7, negative 15 over 7. Now we can multiply 7 everywhere. Our ox equation, m equals to 5, m equals to negative 3. So our x c1 e to the 5t plus c2 e to the negative 3t. And then we had y equals 1 over 7 dx minus 4 over 7x. So if you find dx, we have a 5c1 e to the 5t minus 3c2 e to the negative 3t. Plug it in. Y equals to 1 over 7 dx 5c1 e to the 5t minus 3c1 e to the negative 3t minus 4 over 7x c1 e to the 5t plus c2 e to the negative 3t. And y equals 5 over 7 minus 4 over 7. That's 1 over 7 C1 e to the 5t. Negative 3 over 7, negative 4 over 7, negative 7 over 7, minus C2 e to the negative 3t. So now we have solutions for x and y.